You are with Cape Talk.
Views and news with Clarence Ford.
Dr. Chris Smith is waiting for your question. Welcome, Chris. It's great to have you.
Hi, Clarence. Good morning. And I've done my homework this time. You'll be pleased to hear. You're not going to get me into trouble this week.
Are you talking about that 7 billion year old little thing that's going through our solar system?
Well, it's not one. There's of course two interesting comets that you pointed to. One perhaps a bit more interesting than the other. The two are Comet Swan. Now, this was seen by our SOHO instrument, which is a heliospheric observatory. This is looking at the sun, but has instruments that can look at other things that sweep into the field of view. That one was picked up at the beginning of September, Swan. This is a comet within our own solar system. It will come probably about 39 million miles away from the Earth at closest approximation, which will happen later this month. On the 20th of October is its closest pass. That's on about a 650-year orbital path. So if you live long enough, you're going to see that come back, that one. Probably at that sort of distance, hard to spot for us here on the ground, though. The more interesting one you pointed to was one I hadn't realised had come along. And there's this old saying, isn't there, that you wait for a bus and then three come along all at once. Well, we wait for something to come from outside our own solar system. And then in the last decade, three interstellar travellers have all come at once. There was one called Oumuamua in 2017, this long cigar-shaped object that came from another system. There was another one in 2019, an object that came into our solar system from interstellar space. Now, this one, Atlas, which was actually called Atlas, it's been named Atlas because it has been seen by an amazing telescope which is called the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in Chile. This object is doing about 58 kilometres a second, and it won't get anywhere near us. It'll be about 200 million kilometres away at closest pass. But based on what we've learned about its trajectory, this did not originate from this solar system. It's not like Swan, which is one of our own comets. This one has been kicked out by another system, presumably billions of years ago. It's been travelling across space, and it's been captured by and deflected by the gravity of our system, and it's just passing through. And it will pass, if you do get to see this as a dot in the sky, a bit later on in the month, you won't see it again because it's not coming back. We can tell from its trajectory it must have come from interstellar space, and that's where it's destined. It will go back into interstellar space. It's sort of just swooping through our system on its way across the universe. Isn't that amazing?
It is. It is.
So thank you for pointing me at those. I hadn't realised that this was up there in the night sky. So I did an interesting bit of reading this morning and enjoyed doing my homework very much.
Okay, let's go to the very many telephone calls that are waiting for us. Are we going to go to Janus first? Or, no, we're going to Zuki first. Welcome, Zuki. It's been a while, although I hear you elsewhere.
Hi, Dr. Chris. Okay, so I love pineapple. I love it to the point where I eat it so much and it hurts and I still carry on eating. So my question is, I believe it's the bromelain that causes that sensation. So what is the bromelain actually doing, number one? And number two, is there any way to counter it or like speed up the downtime before I can have more pineapple?
Hi, Zuki. What Zuki's referring to, if you eat fresh pineapple, you can't do this with the tin stuff because they add stuff to the tin stuff to deactivate this process. There are enzymes, which are small molecular machines that can speed up chemical reactions, which are present in fresh pineapple. One of them, bromelain, is a protein digesting enzyme, and we can use it as meat tenderizer because it breaks down the kinds of proteins that make up connective tissue and meat. But when you eat this enzyme, it also can't tell the difference between a steak you've put it on and the inside of your mouth. So it will begin to break down the inside of your mouth. And this is why your mouth feels prickly after eating a lot of pineapple, like Zuki's saying she does. Why is it there? Well, various plants make various chemicals. They have various roles in those different plants and chemicals. Often protein digesting enzymes are there as a form of defense. So if something injures the plant, it can break the thing down. It can also use it to dismantle proteins that it makes itself. And sometimes it's used in order to heal up a wound. So if you damage a piece of fruit, you'll notice it goes, particularly an apple, a bit brown where you dent it or bruise it. And this is where you damage cells, they release sequestered enzymes which are kept safely in certain compartments in the cell where they can't do damage. When they're allowed out, though, because you physically burst the bubble that's got them in, they start to act on the other tissues. And so a bruise is because you've released these enzymes, which are then breaking down the tissue in the healthy fruit around themselves. And there are various reasons why that would happen, but this is probably what it's doing in pineapple. And we would normally use it to tenderize a steak, but if you eat too much of it, it will tenderize the inside of your mouth, as Zook is found to painful effect.
Janus, welcome. Yeah, good to have you. Go ahead for the Naked Scientist.
Hi, thank you very much. Hi, Chris. Is our brain our friend or our enemy? We know that our brain is one of the best computers they ever could imagine. We could imagine, and some of the people got the fantastic memories, and they can remember many things from the 40, 50 years. But is it a gift or the curse? Because some of them, I know, they cannot sleep properly because it's affecting them. They're thinking all the time what happened and how we can sort it out. Is it also for instance, like in computer, you can put some memory into the dustbin or something. Is it anything done regarding to that where we can rest our brain because it's affecting us? We know about magnetic field from inside our brain and outside as well. Not mentioned, for instance. Remember, a long time ago we had this discussion, and when there was a tower, 5 giga towers, and there was a noise about it. Now 7, and nobody talking about it because it's a normality. So how can our friend how can a brain be more friendly to us and more relaxed life?
Thank you, Yunus. Thank you, Janus. Is our brain our friend or our enemy?
Hi, Janus. This is a really interesting point, this one, because we think having a really good memory must be a fantastic advantage. And up to a point, it is, because you can remember things and then learn from experience. But as he alludes to, not all experiences are positive ones. And if you're not careful, you could end up with a head full of negative thoughts, which would bear down on your mood and well-being and ability to enjoy life. So psychologists do believe that we have mechanisms in our brain that help us to forget on purpose. They soften memories and particularly prioritise the softening of bad memories. Really, really bad things, we do remember those, sometimes to bad effect if you develop conditions like post-traumatic stress disorder, which can be because of particularly harrowing or emotionally hard to deal with encounters or exposures or situations. But usually we do have a mechanism in place, we think, to soften memories, to tend to bias us towards the good. So we tend to look back with nostalgia at the good old days. Things were always better in the good old days. We think that is actually an intentional mechanism for precisely the reason that Yunus is highlighting, which is that if we filled our head with bad ideas and bad thoughts, we would really struggle to enjoy life. And so we do tend to look back nostalgically, look back sentimentally on how good things were before, and conveniently overlook many of the bad things that used to happen as well. Probably intentionally. It's probably an adaptive trait that we do that. So we do have good memories, but they're not perfect. And many people, when tested, although there are some things we do take steps to record faithfully, there are many things where our memories play tricks on us and they fill in gaps and we don't know what we've forgotten, and our brains conveniently fill the gaps with invented things, a bit like trying to use AI and it confabulates stuff. Our memories aren't perfect and they tend to fill the voids with better views and better opinions than those that prevailed at the time.
Barris is in Bloberg. It's been a wait, Barris. Welcome. Okay, I think Barris couldn't wait any longer, unfortunately.
Your call has been played.
But I think Barris's question is about waves. I think the question is around, do waves come in sets of 7?
Well, people say they do. I remember when I used to go down the beach with my dad and he would say, count the waves and the next one's going to be a really big one. There's a kernel of truth in this, in the sense that waves can do what we call superposition. You've probably heard the stories of mariners who go out on the ocean and they'll say, all of a sudden along came an absolutely enormous freak wave. Well, where did a massive wave like that come from? Because at the end of the day, waves are a rise and fall in the height of the ocean. And this is because when you've had a long fetch, the wind blowing across the sea surface, and often when the wind is in opposition to the tide, you then heap up water. And those waves move, as waves do, across water, moving very fast in deep water, and they slow down in shallower water. But that process doesn't suddenly amplify and give you one massive wave. So where would a massive wave come from? Well, the answer is when waves actually arrive at the same point in time, and light does exactly the same thing, the waves superpose, they add together. And if they are in phase, so in other words, one wave coming from one direction is going up at that moment, and another one arriving from the other direction is going up at that moment, they add together, and you have a big wave, which is the combination of the two. They can also cancel each other out for the same reason. So if you have waves arriving at a shoreline from a certain direction, it's possible that this process has arrived with waves arriving from two different sources. Sometimes they're in phase, they're arriving lined up and they're bigger. Sometimes they're arriving out of phase, one's going up, one's going down, they cancel each other out, and so you get a wave that gets a bit smaller. So there might be a numerical relationship there from time to time, but it's not a rule that you could rely on and say, therefore I'll count and the seventh one will always be the big one or the small one. Not going to work like that, but people tend to notice patterns that involve small numbers because our brains are good at doing that, so that's probably what's going on here.
A question in from Andre to the Naked Scientist via WhatsApp and 072 567 1567. It's 12 minutes to 10. Still some time for you to get your questions through. Andre says, Naked Scientist, is there anything biological or natural about the mother instinct in the human species, or is it socialized? In other words, do women have a greater capacity for compassion and nurturing?
I think there is a sex difference, and this is also manifest in other neurodevelopmental situations. I was talking to Simon Baron-Cohen, who is now Sir Simon Baron-Cohen, who has been a pioneer of understanding autism. And one of the points he makes, and he wrote a book about 25 years ago called The Essential Difference, which was looking at the difference between boys and girls and pointing to the fact that you more often see autism-like tendencies in boys, and therefore is autism extreme maleness. So there does appear to be a difference in the way that male brains and female brains think, and one of the most stark differences is in empathy. Males tend to score less well on empathy than females do. And one way to test and probe this, and this was the first time I saw this in Simon Baron-Cohen's book, and it's a really good book if you want to read it, by the way. It's called The Essential Difference. He shows that the test that psychologists do, where you show people a picture of a face, but not the whole face. Imagine a person where you've blocked out most of the face and you can only see the patch of the face where the eyes are. Imagine looking at a person through their letterbox, the bit of their face you would see, and they show you 4 words, one in each corner of the picture, one of which matches the most likely emotion that person is displaying. The rest of them close match or nothing to do with it. So it might be a face that you think, oh, that looks a bit sad, and it would say sad, happy, aroused, concerned or something, and you'd have to pick the best word that best went along with the mood of that person's face. Women score much, much more highly on this, on average, than men do. And therefore, if you do the same thing in people with autism, they score abysmally, on average, on this. So there does appear to be a difference between males and females' brains. Empathy is one of those big differences, and this does appear to map onto a nurturing instinct, and therefore perhaps, and this may be hormonally driven, I don't think we really know, but that might account for part of the maternal instinct that we see. And why? Because if people, especially women who are having babies, were not able to think for that baby as well as they do, that baby probably wouldn't have as good an outcome as a person who's thinking, how is that person feeling? What are their needs? What can I do to make that baby as healthy and happy as possible? And that probably is part of this.
It's decided then, men are from Mars.
Quite possibly. Yeah, I don't know about me. Maybe.
Let's go to Keith. He's got a voice note in.
Scientist, I wonder if he can answer a question for me. What's the difference between colloidal silver and quantum silver? And what is the properties of silver? Is it a bacterial, or is it an antifungal, or is it just an ordinary natural sort of antibiotic? Thank you.
Hi, Keith. I'm not entirely sure about this, but I think this is a reference to the fact that there have been people who have been admitted to hospital from silver ingestion, and there was a guy who ended up looking like Papa Smurf. I think he's died now, but he ended up completely blue because he read somewhere silver is really good for you. So drink this silver solution. And he was drinking large amounts of silver, relatively speaking, and silver migrates into the skin. And just as in a photograph, silver grains react in the presence of light. In the skin, silver grains react with light and they tarnish. And he developed the condition argyria. AR being the chemical symbol for silver, and he went blue. So don't do that. But we do have great uses for silver because it has interesting chemical properties, and this is where the nanodots of silver come in. We can make tiny particles of silver and functionalize surfaces with them. You can print those nanodots onto a surface, and silver is very good at driving certain chemical reactions and liberating free radicals from things like oxygen. So they therefore are naturally antimicrobial because the surface makes things, chemicals, at low levels which are highly toxic to microorganisms. So if you put microbes down on a surface and it's been coated in silver particles, the silver will poison the microbes. There are also ways of using silver to sterilize water. You can put small amounts of silver in water in sunlight, shake up the water. The silver makes from the air that's mixed into the water free radicals that poisons the microbes, and you end up with a safe drink to drink. But if you end up with too much silver in solution and you drank that, you'd end up like the bloke who went blue. So be careful.
Then we got a voice note from Jen, but a question in as well about the limit to the number of popular riffs or tunes musicians can create using guitars. Will artists start repeating tunes when they've run out of new ideas? The question, two questions, and we got 2 minutes left. It's going to be a tall order, but let's take a listen to Jen.
Hi, it's Jen here. Can the Naked Scientist explain to me how diamond coated and titanium coated non-stick pans work?
Oh, I didn't know people were coating pans with diamonds. I'll have to have a look at that, Jen. That sounds interesting. Does it affect the cooking? I don't know. I wasn't aware people were doing that. Obviously, non-stick, that's a totally different substance. I mean, that's something we've had for a very long time, but I didn't know people were doing it with diamonds. So tell you what, I'll take that one away as homework and do a bit of research for you on that one. On the musical one, this is interesting. And there are so many possibilities, because if you think about how many notes we've got and you think about how many different octaves you can get and combinations of those notes, and it's a bit like saying, with all of the letters in the alphabet, won't we run out of words to write and therefore run out of stories to tell? Most people accept that the number of degrees of freedom is so high that the likelihood of us ending up with the same patterns repeating themselves is so low that we'll end up with something else killing us off as a population before we run out of songs to sing. Thank goodness.
You know what? We've got a minute left, so let's see if we can push it. I thought autism affected males more, but actually this is because it manifests differently in females, so it wasn't being diagnosed. I think it's more of a statement than a question in respect of your earlier reference to it. I don't know if you have a response to Joe.
I've spoken to Simon Baron-Cohen about this, because if people want to hear the inside story, we actually did a Titans of Science episode, an in-depth interview with Simon a few months ago on The Naked Scientist. So if you look up The Naked Scientist podcast and Simon Baron-Cohen, there's half an hour really in-depth conversation on this. But to an extent, what we think is, yes, women are diagnosed with autism, but less frequently than men. Now, part of that might be lower levels of pickup, but when you control for that, you still see a greater number of males being diagnosed than females. So we think that part of it might be there's under-recognition in both sexes, but there does seem to be a greater number of males being diagnosed than females.
I'm going to push it. I may suffer the wrath of Joe. What does the Naked Scientist think of ivermectin for rectal cancer? From Sandy.
Sandy, I've never heard of anyone using ivermectin, which is an anti-worm or anti-parasite drug, to treat rectal cancer, I would be very cautious about hearing something on the radio or reading something that hasn't been the subject of a proper clinical trial. The best filter to apply is if a drug has been properly tested and evaluated in a placebo-controlled way, people given the drug with the condition, people with the condition and given a dummy drug, and you compare the outcomes, that's the gold standard. And when you've got that data in front of you, then you can reasonably interpret it's been evaluated properly. But until that point, be very, very cautious about any kind of claims you read online.
I've got the look from Joe. Got to wrap it there, but in appreciation again, Naked Scientist, a really huge appointment, and you answer them questions. Dr. Chris Smith, a lecturer at the University of Cambridge, back every Friday just after 9:30.
You are with Cape Talk.
Views and news with Clarence Ford.